This webinar is designed to discuss the 7 most frequently asked questions we get here at Iris regarding, infrared windows, their installation, etc. And really, these are the 7 points that you need to assure yourself of before you enter into an infrared window program. So, number 1, size. What size of infrared window do you require? Round windows, even when you use multiple windows, really are not suitable to show you what you need to see a lot of the times in switchgear. If you look at switchgear, standard switchgear has large rectangular windows, visual windows, and really where we're coming from in Iris is, you can look at the design of the switchgear that you're utilizing, and you should be able to get a window that shows you everything you need to see in one window instead of putting multiple windows in. If you look at this slide here, the picture shows 12 round infrared windows. Now that's 12 4-inch crystal windows and 12 installation costs. These are a non-impact, resistant, and mechanically inferior design, and so they're very expensive, very expensive. Where if you look at the way we do things at Iris, we build custom systems. So the top window is a direct replacement for the visual viewing pane. Because it uses clear polymers, you can still do lockout, tag out. And the lower window is one of our CAP CT24s. Again, so we've got 2 windows to replace 12 round windows. It shows you more, and it costs a lot less, about 40% of the cost of the round window solution. The other things that we can do is design other windows. So if you look at the images there, we have curved windows for your isophase bar bus, for instance, ultrasound ports, the tap-off units. We have the panel board click-in, like quick fit windows. So we've got a whole bunch of different solutions to meet your requirements. This visual here shows that basically if you look at the lower image on the right, this is a 12-inch depth with a CAP 12 window, which is a 12-inch wide infrared window, versus the 4-inch windows. You can see that a CAP 12 will show you more than 4 4-inch windows, and the other thing that's important about that is about 50% of the cost of 4 4-inch windows. So it's a lower cost solution, which is, so it's financially, it's a much more beneficial system to use, as well as mechanically and as an infrared window system. It's a much easier system to use because it shows you everything you need to see. So number 2, are your windows mechanically stable? The majority of infrared window failures are due to breakage from direct or indirect impact. That's what we see in the field. So make sure that the window you're going to utilise meets the requirements of UL 1558 or IEEE C3720.2 section A.3.6. But this testing should be done covers open. So one of the problems that we see with, for instance, the IEEE C37 standard, this is a standard for visual viewing panes fitted in switchgear above 1 kV, where there's a mandatory impact test requirements from both sides of the window, and it clearly states that it mustn't crack, shatter or dislodge. Well, all of our crystal units on any crystal unit cannot take a direct impact test. So that cannot meet this standard. The UL 1558 standard, which is the twice the load and twice the impact of the IEEE, can be done with the cover fitted. And if it's done with the cover fitted, the pass criteria is you cannot pass a 1/2-inch rod through the cover, which isn't a very good test to do because the infrared window lens is shattered, so that's gone. But because there's a cover in place and you can't push a rod through the cover, it passes. So if you're going to use UL 1558 or IEEE C37, make sure that you do the test with the covers open. Now we clearly state just because something's been around for a long time doesn't mean we can't improve on it. And at Iris we started with crystals, but we've improved on the design. There was a requirement for impact, load, flammability, fail-safe. So the design that we utilise, it meets all of those requirements. This is an impact test of a VP lens system. You can see I can clearly take a 5-pound sledgehammer to this lens system and it still remains intact. This is what you need for industrial systems. You don't need a system that's going to break or fail. Another question, number 3, are the windows environmentally stable? And as I've said earlier, the crystal windows are hygroscopic. That means they absorb water, acids and alkalis from the atmosphere around them. And that blocks the infrared transmission from the crystal. So that's a big problem, because if the transmission is changing, How do you know what settings to put on your camera? So we always say, that you need something that isn't going to let you down. And crystals, because of their hygroscopic and fragile nature, will change. The transmission will change. And if that transmission changes, how can you calculate the temperature? So again, we stipulate for industrial infrared windows that crystals don't really work. I mean, on certain websites you'll see that they recommend that you do calibration checks twice a year, and etc. etc. You can't do that when this is installed in an energized electrical system. You have to put it in, and it needs to be there, and you can check the transmission between services, but you need to be able to rely on it not to change on you. Another problem that we see with crystals is they fog. The actual mass of the crystal. If you chill it down and in the morning you have a humid environment, then you'll get humidity form on the sensor, or it will fog over. And because water blocks the transmission of infrared energy, you can't use it. It has to, you have to sit there and wait for it to defog, and then you can do your inspection. So this is another issue that we see with crystal infrared windows. Do all the windows have all the relevant testing certifications? Now, there's a whole myriad of test requirements for infrared windows or visual view, and we tend to test our infrared windows to the same standards as visual viewing panes because they've been there for a long time. So you've got standards from IEEE, ANSI, IEC, UL, CSA, NEMA, etc. I mean, you can go on and on and on. I mean, if you're in the marine market space, then the DMV and ABS and Lloyd's are very important standards to you. So again, look at what you need to be doing, look at the windows where they're going, and then if you're unsure, speak to the OEMs or even speak to us here at Iris, and we can give you some advice on what standards you need to comply with to meet these requirements. Now, number 5 is, are the windows arc containment tested? Now, again, there's no such thing as an arc resistant infrared window, and this is a very contentious subject when it comes to infrared windows or visual viewing planes. Now, there are a whole bunch of things that we can do with regards to the mechanical testing, bending, flammability, impact, vibration, environmental testing, etc. But the arc containment test is a part of the actual overall system. So when we have arc containment testing, for instance, we've had a whole bunch done in arc resistant equipment. Well, that type of test, when we do it, we see maybe 950 Celsius peak temperatures and at peak pressures of about 25 to 28 pounds, and then a burst valve opens and releases all of that pressure, temperature, etc. So the systems are designed in arc resistant equipment to protect themselves and protect the operator. Now, we at Iris, what we did was we were trying to come up with a way of testing the arc containment strength, not arc resistant, arc containment strength of our EMV and VP systems. So we did a test of our VP and CAP systems to the IEC 62271-200 requirements for metal clad switchgear. Now, this doesn't relieve the pressure on the products that we test. It's a really strong test, and what we're now going to look at is the video from that test. So what we did, the test voltage was 6 kV. The test current was 31.5 kA, but the peak current that we seen on the test was actually about 83,000 amps. The test period was for 1.1 amps, and the overpressure within the box was in excess of 18 bar, because what happened, the instrumentation within the box burnt out and went at about 18 bar. But a really tough test to pass, and this was what we did to prove the arc containment strengths, not arc resistant, arc containment strengths of our VP and CAP series products in metal clad systems, which would exceed the requirements of any arc resistant system. Now, number 6, do you have windows, do they have an ID or information tagging system? Now, again, infrared windows are a data collection point for an infrared camera, if you look at it that way. And there's a bunch of information that really the operator would like to have at that window that tells them, the camera transmission, the targets, if there's some history, etc. Now, again, it can be as simple as a write-on label, or as complex as what we have in Iris, which is our eSentry Connect Smart Tag systems. Now, the eSentry Connect Smart Tag system is an NFC tag. You get a free app from Iris, and these tags are built into our CAP series and custom series as standard. Now you can have a free site-based standalone system, which you can basically look at the inspection information. You can save it to it, equipment data. There's a notes field. You know what the inspection parameters are in there, so the inspector can open that tag, look at everything they need to do with their camera, what they need to inspect, what transmission settings need to be done. So it's a really good tag. And then there's a cloud-based or site-based system that's a subscription-based system, and that enables you to do a whole bunch more. But again, the tagging system could be as simple as a write-on label, or as complex as our eSentry Connect smart tag systems, but you must ensure that you have some element or some way of recording this data locally. Now finally, the most important question I think is the manufacturer's warranties for IR Windows systems. You need to ensure that the warranty system on your window is there. And this is a large investment on behalf of your customer, your own requirements, and also you want to make sure when you install it, you're going to get accurate data for it. So the warranty or guarantee from the manufacturers is important. Now you will find that any crystal manufacturer, because this is physics, they fail. They fail through impact, they fail for hygroscopic failure. But you'll see that they will offer you manufacturer's defects only against their warranties. They won't offer you a guarantee against the failure of the crystal, because that's a material failure. And if the crystal fails, as it will, then a material failure is not a manufacturer's defects. So you have no way to go on that. So again, what you want to do is look for an unconditional lifetime warranty on the lens system in your infrared windows that you're going to be using, and that you can only get from Iris. So, just as an overview, what to specify? The size of your infrared window system should meet the requirements of your tasks, your needs. Don't put multiple round windows in. Use large format windows or custom windows. It actually, in fact, from a custom window system, you save a lot of money on the install, and you can install a lot more. So if you've got a limited shutdown, custom windows can really help out. Ensure your IR window lens systems are mechanically stable, and suitable for your environment. So if you're working in a heavy industrial environment, you want things that are impact resistant and can meet those requirements. The environmental suitability for the application is very important. If it's very humid or dusty or dank or high frequency, a lot of high frequency noise around you, make sure that your Windows environmentally suited. Now, when you look at the NEMA rating or IP rating, you cannot go down an IP rating. So if you have an IP67 panel, a weather enclosed panel, your Windows system has to be IP67 or above. If it's an IP55, then it has to be IP55 or above. But you cannot degrade the panel by putting in a lower environmental rating. Ensure your IR windows meet the test and certification requirements for your application. If you're unsure on this, speak to the OEMs, they'll tell you what you need to know. Or you can contact us here at Iris. We have a myriad of information that we can share with you on this. Review the arc containment test data for your application. Now, a lot of panels, there is no arc containment. So if it's an IP55 panel, which has open grills and vents everywhere, that's not designed to maintain or contain a arc flash event. But again, arc containment is an important thing. It proves to you the strength of the system you're installing. But be very aware, arc containment tested is not arc resistant. Arc resistant does not exist. A core temperature of 35,000 degrees Fahrenheit in an arc flash event, it's coming through a panel if it's close enough. So again, be very aware that arc containment is not arc resistant, because arc resistant doesn't exist. Ensure your IR windows have an information tagging system. As I reviewed with you earlier, it can be as simple as a write-on tag, or as complex as our eSentry Connect systems. Ensure your IR windows are supplied with an unconditional lifetime warranty. This is important. It's a large investment on your behalf, and you want to make sure you're protected. So in summary, your critical asset surveillance program is a valuable resource, and great care needs to be taken when choosing the electrical maintenance safety devices to enable closed panel access for cast equipment, especially when it comes to infrared windows. An infrared window program is a significant investment, and it requires you that you really complete your due diligence, ask the right questions before finalizing on the type of lens you're going to use and the sizes of infrared windows that you require. Now, more information on infrared windows and other EMSDs can be found at iris.com. And again, thank you very much for taking the time to listen to this presentation. And if you have any questions relating to any of this, again, come back to us at iris.com. Thank you.